pleasant day to all teachers, students, and panelists in this first Division Virtual Research Festival. We are the students of Science, Technology, Engineering, and Mathematics of Barobo National High School representing Barobo District 1. At this moment, we present our study entitled Utilization of Rice Husk Biochar and Cuttlebone Powder as an Alternative Fertilizer for Chinese White Stem Cabbage, Brassica rapachinensis. Rice hull or rice husk has long been known as the most abundant agricultural waste in the Philippines, with 2 million tons of rice hull being produced in the country annually, with only 5% being used as soil substrate and cooking. Cuttlebone or cuttlebone powder is rich in calcium carbonate, which is widely used in crops to neutralize acidity and supply calcium for plants. Due to this, the proposed study will provide knowledge on alternative organic fertilizer using rice husk biochar and cuttlebone powder that will be less expensive, more sustainable, and environmentally friendly but does the same function.
For the objectives of the study, in general, it aims to evaluate the viability of rice husk biochar and cuttlebone powder as an alternative fertilizer for Chinese white stem cabbage, Brassica rapachinensis. Specific objectives: 1. To analyze the nutritional contents of the formulated fertilizers from the rice husk biochar and cuttlebone powder. 2. To determine the growth rate of the Chinese white stem cabbage fertilized with rice husk biochar and cuttlebone powder. 3. To compare the growth rate of the Chinese white stem cabbages applied with different treatments. The findings of this study will benefit the agricultural business, particularly the farmers in Surigao del Sur, where rice husk and cuttlebone are abundant, as they will be able to use a cost-effective byproduct and a non-synthetic fertilizer for their crops.
The gathering and processing of the cuttlebone and rice husk were all conducted at Purok 1A Poblacion, Barobo, Surigao del Sur. Investigation of the performance of the treatments were measured through its morphological characteristics. The whole observation and investigation period was conducted for 10 days.
Materials and methods. For the formulation of experimental fertilizers, rice husk and cuttlebone were utilized for the present experimentation.
The rice husk collected has undergone pyrolysis to produce char or biochar by partially burning it at 250 to 300 degrees Celsius for 8 hours. The cuttlebone collected was sun-dried until excess moisture on its surface evaporated. After drying, the cuttlebones will be powdered using mortar and pestle. Hence, rice husk biochar and powdered cuttlebone were used for the formulation of fertilizers following the treatments of the study. There are 6 grams of formulated fertilizers used in treatments 1 through 5. For every treatment, there are 3 replicates. Hence, each replicate will have 2 grams of formulated fertilizers. The researchers ensured that the formulated fertilizers were mixed well before applying to each replicate in every treatment.
The experimentation process had 6 treatments in all. Treatments 1, 2, 3, 4, and 5 were applied with formulated fertilizers. However, treatment number 6 remains untreated and will serve as our negative control.
Experimental design using complete randomized design was used in the study using the following treatments. Treatment number 1 had 3 replications of Chinese white stem cabbage treated with 50% rice husk biochar plus 50% cuttlebone powder. Treatment number 2 have 3 replications of Chinese white stem cabbage treated with 75% rice husk biochar plus 25% cattle bone powder. Treatment number 3 have 3 replications of Chinese white stem cabbage treated with 100% rice husk biochar. Treatment number 4 have 3 replications of Chinese white stem cabbage treated with 100% cattle bone powder. Treatment number 5 have 3 replications of Chinese white stem cabbage treated with 100% NPK fertilizer or the commercial fertilizer. Lastly, treatment number 6 have 3 replications of Chinese white stem cabbage untreated and will serve as the negative control of the study.
From the data collected, the researchers drawn these following results. The researchers determined the nutrient components of rice husk biochar and cattle bone powder from Schroeder 2012.
Based on Table 1, it is found out that the rice husk biochar is mainly composed of these following elements: 171 mg per kilogram of silicon, 220 mg per kilogram of calcium, 175 mg per kilogram of magnesium, and 182 mg per kilogram of potassium. On the other hand, these are the contents and properties of cattle bone powder. Acid insolubles 1.4%, moisture content 2.3%, calcium 85%, magnesium 0.42%, potassium 63 mg per kilogram, total nitrogen 8,300 mg per kilogram, and total phosphate 20 mg per kilogram.
The growth rate of the petri plant was determined through the measurement of the following morphological characteristics: plant height, leaf length, and leaf width.
In Table 2, which measures the growth rate of the plant height, it was determined that the highest average growth rate among the treatments was treatment 3 with an average of 0.73 centimeters. In Table 3, the average leaf length growth rate of the Chinese white stem cabbage applied with different treatments is presented. It is shown that the highest growth rate in terms of leaf length is treatment 2 with an average growth rate of 0.30 centimeters. The data presented in Table 4 are the average leaf width growth rate of the petri plant in different treatments. The average mean of the growth rate shows that the highest growth rate in terms of leaf width among the different treatments is treatment 3 with an average of 0.25 centimeters. The results suggest that there is a significant difference between the initial and final height, leaf width, and leaf length of the Chinese white stem cabbage in every treatment. This entails that all Chinese white stem cabbage has significant growth increment after 10 days of observation using different fertilizer formulation.
In order to determine the significant difference of the initial and final plant height, leaf length, and leaf width, t-test was done.
In Table 5, the highest plant height difference is seen in treatment 1, formulated from 50% rice husk biochar and 50% cattle bone powder. In Table 6, the highest leaf length difference is observed in treatment 5, which used 100% NPK fertilizer. Meanwhile, results shown in Table 7, leaf width difference, revealed that the highest among the treatments is shown in treatment 1, formulated from 50% rice husk biochar and 50% cattle bone powder.
Conclusion and recommendation. The results of this study revealed that the fertilizers formulated from rice husk biochar and cattle bone powder are effective for the growth of Chinese white stem cabbage in the vegetative stage of their growth development. All treatments showed good growth rate. However, the highest plant height growth rate was shown in treatment 3, which was treated with 100% rice husk biochar. The highest leaf length growth rate was observed in treatment 2, applied with 75% rice husk biochar and 25% cattle bone powder. The highest leaf width was observed in treatment 3, applied with 100% rice husk biochar. Therefore, the researchers conclude that rice husk biochar is an ideal fertilizer for Chinese white stem cabbage. It is recommended that the observation of the growth rate using the mixture of rice husk biochar and cattle bone powder will be conducted until harvesting.